Find the area of the region bounded by the following graphs. You have y equals 1 over x squared, you have y equals 0, aka the x-axis, and x equals 2 and x equals 6. Basically what we're looking at, okay, is if I were to draw this guy out on a coordinate plane, okay, we are looking at y equals 1 over x squared is going to look like this up here and then reappear down there and look like that. Okay, you have y equals 0, which is just the x-axis, just the formula for the x-axis, nothing fancy. Now, by putting this at x equals 2 and x equals 6, we care about the area between 2 and 6, whatever that might look like. So we're looking at something that looks a little something like that. So what you're going to do is you're going to label these two graphs f of x and g of x. Now, if you're drawing this out, try to label the upper graph f of x and the lower graph g of x so that when you do what we're about to do, you'll get a positive area. If for some reason you do this and you get a negative area, you're not wrong. Just make it positive and you'll be just fine. All right, but the formula that we're going to use is going to be the integral from whatever a to whatever b, so in our case 2 to 6, of f of x minus g of x dx. And this is us finding the area between the two curves. So setting this up over here, I decided to call f of x 1 over x squared. So I'm going to have 1 over x squared minus g of x, which is a big fat nothing. Now my limits of integration are going to be 2 and 6 because that's the x values that were given here, dx. Okay. So you do a little bit of integrating. I mean, maybe not yet. Maybe if I wanted to clean this up, I would say between 2 and 6 of 1 over x squared dx. And I don't like the way that looks. So between 2 and 6 of x to the negative 2 dx. Okay. And then that becomes, what is that? Negative 1 over 1. So negative x to the negative 2 plus 1, which is negative 1. Limits are 2 and 6. Okay, so the integral of x to the negative 2 is negative x to the negative 1. Let's clean that up a little bit. Make that look like negative 1 over x with the limits at 2 and 6. Okay, now we'll plug in our limits of integration and do a little bit of mathy math. Negative 1 over 6 minus negative 1 over 2. So I'll keep that negative 1 over 6, negative 1 over 6. We'll make that double negative a positive. We'll make you 3 over 6, giving us, what is that, 2 over 6, giving us 1/3, which is going to be C. So that's how you do that problem. Isn't that fun? So much fun. Find the area of the region bounded by the following graphs. We have x squared and we have y equals x to the third. So we kind of know what these guys look like. All right, x squared is just a little parabola. So if I were to graph this over here, all right, and you'll see what we're going to focus on. X squared is a parabola. So I'll make you green. Look something like this. And then x to the third since it's just x to the third, it's going to kind of look like this. All right. So maybe I'll scooch you down just a bit. I'll scooch you up just a bit, and everybody's happy. So what we're trying to find is that little area right in here, that little sliver right there. So this is what we need to do. The formula for finding an area between two graphs is you take the one function, right, and you subtract the other function. What we also need to do is we need to find our limits of integration, which we don't know yet. I need to find out where these guys intersect. So I need to find out what you are and what you are. So if we need to find out where they intersect, we take these guys and set them equal to each other. So x squared equals x to the third. So why don't I subtract x squared from both sides? So we get 0 equals x cubed minus x squared. Let's pull out an x squared, so 0 equals x squared, leaving us with x minus 1. And using the zero product property, we get zeros at 0, so x equals 0, and positive 1. So my limits of integration are going to be a, b, 0, and 1. So you're 0, you're 1. Okay, so now I have everything I need. Now, according to the graph that I drew, you really want to have the upper graph be your f of x. So it looks like the x squared is going to be my f of x, and x cubed is going to be my g of x. If you have this backwards, then what's going to happen is you're going to get a negative area. You're not wrong, just make it positive and everything is fine. You can't have negative area in a real world sense if we're talking about that. So you just make it positive, no big deal. That's going to happen from time to time. But the integral that we're going to set up is the integral from 0 to 1 of x squared minus x cubed dx. Okay, so integrating that is going to give us 1/3 x to the third minus 1/4 x to the fourth with limits at 0 and 1. So we plug stuff in, 1/3, 1 cubed, minus 1/4, 1 to the fourth, right? Minus 1/3, 0 cubed, easy. Minus 1/4, 0 to the fourth, easy. The entire right side, the entire right bracket is just going to become 0, make it go away. This becomes 1/3 times 1, so 1/3, minus 1/4 times 1, so 1/4. Okay, let's make these over 12 so we can combine fractions. So you're going to be 4 over 12 minus 3 over 12, which is 1 over 12. So that little tiny sliver isn't a whole lot, but that sliver accounts for 1/12 square units. And that is our answer, baby. Find the area of the region bounded by the following graphs. We have y equals x and y equals x squared minus 6. So if I were to draw just a little picture, okay, of what's going on here, y equals x squared minus 6. Let's actually move u up because that's going to be probably the more important part. Y equals x squared minus 6 is just a regular old parabola shifted down 6 units, something like that. Okay, that's what u is. Y equals x is going to be a linear equation going through that. Oh boy, good job drawing a line by me. No one will ever know. Now, the function for finding the area bound by two graphs is going to be the integral with limits of integration a and b of f of x minus g of x dx. A and b are where these two lines intersect. So I have to find out where these two lines intersect. And then what I'm going to do is I'm going to take the upper graph, which appears to be the linear equation, and subtract out the lower graph, which appears to be the parabola. But first, like I said, we have to find out where they intersect. So I'm going to set these guys equal to each other. I'm going to have x equals x squared minus 6. Let's subtract x from both sides. 0 equals x squared minus x minus 6. Factor that out. X minus 3, x plus 2. And my zeros are going to be at positive 3 and negative 2. So those are going to be my limits of integration. I'll make the smaller one a, the larger one b, like so. And now we have enough ammunition to plug stuff in. So I have the integral from negative 2 to 3 of f of x, which we're calling the linear equation, x minus g of x, which is x cubed minus 6. Now, if you're like, what if I have that backwards? Then you're going to get the same exact number, but it's going to be negative, and you just have to realize, oh, since I got it backwards, the answer is going to be the opposite, so it's going to be a positive whatever. So if my answer is negative 50, the actual answer is positive 50. So let's go ahead and do this. Let's rewrite that out after distributing the negatives. So negative 2 and 3, x minus x squared plus 6 dx. And let's integrate that. So you have 1/2 x squared minus 1/3 x cubed plus 6x with limits at negative 2 and 3. Ugh. This is not going to be fun. All right. That's my song. 1/2 3 squared minus 1/3 3 cubed plus 6 times 3 minus 1/2 negative 2 squared minus 1/3 negative 2 cubed plus 6 times negative 2. And we're going to use all this space because I have a feeling we're going to need it. All right, we've got 1/2 times 9 minus 1/3 times 27 plus 18 minus 1/2 times 4 minus 1/3 times negative 8 plus or minus 12. Not plus or minus, just minus. It's not a quadratic formula. Oh, we have fun when we screw up. We got 9 over 2. We've got negative 1/3 of 27 is negative 9 plus 18 minus, we've got half of 4, which is 2. Negative 1/3 of negative 8 is positive 8/3 gross minus 12. That is going to be let's kill birds with 2 stones. I'm leaving it. I'm not editing anything. A negative 9 plus 18 is going to be 9. So let's make that 18 over 2. Okay. What is that? Negative 10 plus 8 over 3. So let's make 8 over 3, and negative 10 is going to be minus 30 over 3. Okay? See what I did there? That is going to be 27 over 2 minus negative 22 over 3, which is going to be, let me see, we got a double negative here, so I want to multiply the top and the bottom of this one by 3, so 27 times 3 is 81. So we got 81 over 6 plus 44 over 6, which ends up being 125 over 6. Does that simplify? No. So that's our guy. Whew. So yeah, that's what this whole region is. That whole region is whatever 125 over 6 is. So not pretty, but neither's your mama. Thanks for watching. Bye. Find the area bounded by the curves y equals 2 sine x, y equals 1, and x equals pi over 6, and x equals 5 pi over 6. All right, so simply put, 2 sine x is going to look something like this. Something like that. Okay, where it goes up to 2. All right, easy peasy. Now, if it's going to also be y equals 1, that's going to be a line that looks something like that. Okay, that's y equals 1. It just so happens that I know what these guys are because I created the problem. You are pi over 6, you are 5 pi over 6. So we're finding the area in between those two guys, which means we're finding that. Now, the formula for finding the area between two curves is you have your limits of integration, right? You're going to integrate f of x minus g of x dx. Now, which is which? Try to make the upper part your f of x and try to make your lower part g of x. And the reason why we do this is because this will give us a negative or a positive area. If for some reason we have it flip-flopped, it's going to give us a negative area, same number, no problem. We just have to make it positive. So now that I have everything that I need, I can set up my integral, which is going to be the integral from pi over 6 to 5 pi over 6. And we're going to do 2 sine x minus 1. So 2, that's not a sine. That is a line for the x. I don't want that. 2 sine x minus 1 dx. Okay, we can just integrate immediately. So the integral of sine is negative cosine. So 2 sine x is negative cos x. Negative 2 cos x is a close one. And then the integral of negative 1 is minus x. My limits are still going to be pi over 6 and 5 pi over 6. So now we do a little pluggarooski. We plug in negative 2 cosine 5 pi over 6 minus 5 pi over 6. And we're going to subtract out negative 2 cosine 1 pi over 6 minus pi over 6, that 1 pi over 6. So negative 2 times cosine of 5 pi over 6. The cosine of 5 pi over 6 is negative root 3 over 2 minus 5 pi over 6 minus negative 2. The cosine of pi over 6 is positive root 3 over 2, and then we have minus pi over 6. Okay, so a couple things happen. U and U cross out, negatives cross out, U and U cross out. So that leaves us with root 3 minus 5 pi over 6 minus negative root 3 minus regular pi over 6. Okay, let's distribute that negative. And so that leaves us with root 3 minus 5 pi over 6 plus root 3 plus pi over 6. Combine like terms, a root 3 plus a root 3 is 2 of them, 2 root 3's. Negative 5 pi over 6 plus pi over 6 is negative 4 pi over 6. And that guy will simplify out to 2 root 3 minus 2 pi over 3, which is going to be A. Isn't that neat?